So hello guys, welcome back to my channel. This is Nilotpal and you are watching my Shadow EMP unofficial. So yeah, uh, today's subject is data structure and applications. Subject code is BCS304. I'm from third semester and program is computer science and engineering. So in today's presentation, we will explore a powerful data structure that has revolutionized how we manage text and general data. Tries offers an efficient way to store, compress, and cure large data sets, making them a cornerstone in model data management. This season will this session will walk you through their history, principles, and the diverse application that makes them so crucial for today in today's data heavy world. Historical background, the evolution of tries. Tries have been around since 1960s, emerging during the time when the computer scientists were searching for a better method to handle large data sets. Early techniques like linear list, hash tables struggled with dynamic data and fast searches. The introduction of tries offers a breakthrough by allowing efficient prefix-based search, and University of Waterloo project plays an significant role in solidifying tries as a practical tool for large-scale data storage. Uh, in this, as I said, uh, which is also written here in this in this presentation, it says that the concept of tries emerged in 1960s, a period making rapid advancement in computing. This also has an also a time where research grappling and challenge efficient structure and data set indexing. And the need for efficient text search, the limitation of earlier method need leads to development of more so algorithm. Yeah, and the University World Pool project, a catalyst for tries. University of Waterloo project, initiated in 1960, played a pivotal pivotal role in popularizing tries as a practical solution for handling large scale data text data set. Research developers developed a system that relies heavily on tries, demonstrating their efficient real world scenarios and project. Of course, the significance of tries for modern data structures. Fast forward to today, and the complexity of modern data sets requires even more advanced data set. Traditional tree-based da- tree-based structures such as binary search tree faces limitation dealing with variable length data like text or multidimensional data. This is where tries science. Uh, their unique ability to handle shared prefix in data, compress data efficiency, and offer rapid retrieval time makes them an efficient tool for managing and challenging posts today's multimedia, big data, and applications. Data structure evaluation, the development of tries represents a significant shift in data structure. They are capable of handling the unique characteristics of modern data, including the multidimensional data, relationships, and large-scale data set. This evolution has opened up a new possibility for efficient data management in in variety of domains. Core principles. At the heart of tries are few core principles. that are data compression through prefix sharing. Tries reduce storage by sharing common prefix between keys, which is particularly effective for text and spiral data with repetitive pattern. Minimum storage overhead. By eliminating redundancy, Tries provides an efficient way to store large data sets. Efficient data retrieval. They excel in operating operations prefix-based prefix-based search, making them ideal for tasks such as text indexing and spiral queries. Scalability and availability, whether for small or large data sets, tries can scale efficiently, making them suitable for evolving data systems. Mm, Detailed exploration of different try structure. Here they are full tries, ordinary tries, and partial tries, part tries, also known as PaTries. So basically, the full tries says that useful for fixed length data, but can be sourced intensively for long keys. An ordinary try says that compress data more effectively by eliminating redundant nodes. And PaTries, an operative version of tries that saves space by only retaining nodes with multi-branch, ideal for large text data. That's all it says. Like that's the main thing. If you want to read, you could read it. And then we have text indexing and advanced search capability, comprising text for text indexing. Yeah. So in text indexing, tries offer significant advantage over traditional methods like PaTarray. For instance, they require less storage space and allow for efficient search. Try supports advanced search operations such as regular expression search, regular expression search, where patterns are defined with special characters, proximity search, finding terms that appears near each other or other in text, which is variable in natural language processing and information retrieval. Longest repeated substring search, useful for analyzing and recurring pattern with a text. That's what it says. Tries significant outperform traditional searching method like parity in terms of searching and time consuming. For text of size n bytes, the storage required for tries typically much less than n, which while the pat requires space proportional to n. Advanced text search capability. Uh, Regular expression search, proximity search, longest repeated substrings. Tries can efficiently handle regular expression search, where patterns defined use special characters. They allow for the efficient search strings, matches specific patterns. Proximity search, as I said, finding terms, uh, where finding terms and appear near each other in text. Repeated, longest repeated substrings, useful for analyzing and recursing patterns. Tries for special data repeated with tries. Okay. So binary coordinate interleaving. By interleaving binary representation of coordinates, tries can efficiently store and retrieve spatial data. KD tries for multidimensional data. Uh, these are specialized for multidimensional data, allowing for efficient spatial cues. Zoom tries for efficient spatial cues. Design designed for designed to facilitate zooming in and out of spatial data and various levels of details, which particularly useful in geographic information system GIS, as I said. So both came under one self. Generally tries for multi-key datasets. Tries aren't limited to text and spatial data. They can also be applied in multi-key datasets, which where record contains multiple attributes such as custom relation management (CRM) or in inventory management system. By using composed keys, Tries allows for efficient queue across multiple dimensions, ensuring fast retrieval and optimized storage. Use cases in, there is use cases in dataset system. Multi-keys datasets are wide application, including custom relationship, as I said, CRM, and inventory management and financial datasets database. Tries provides efficient and effective solution for managing dataset, providing efficient improving performance and faculty complex searches. So in the end, we come to our conclusion and future directions. In conclusion, tries have become an indispensable tool in data management, offering efficient storage retrieval at ability adaptability for various types of data as the demand for handling ever large data sets grows. Tries will continue to play a vital role in future data structure, whether for text and multi-key databases. The versatility and power of tries makes them a perfect fit for modern database system. So thank you for joining today, and have a nice day ahead. Thank you.